Another special way to write linear equations is called standard form, shown here. ax plus by equals c. A few textbooks have definitions that end here, but most have a little more to the definition. Most definitions agree that a, b, and c should be integers, and even the ones that don't mention it specifically will nearly always write standard form with a, b, and c as integers. A few definitions want a to be not less than 0, and some say that while it's not mandatory, it's customary that a is not less than 0. Some of the definitions are very specific to state that a and b cannot both be 0. This is kind of obvious because if a and b were both 0, you wouldn't have an x or a y left in the equation, and you really wouldn't have much of an equation left. And the final thing that's stated in some of the definitions is that a, b, and c are relatively prime. Again, most books write standard form with a, b, and c as relatively prime, even if they don't state it in their definition. We'll get back to this topic of numbers being relatively prime later in the lesson. Well, let's go now to an equation in slope-intercept form and rewrite it in standard form. For this one, it won't take too long. We're going to add 3x to both sides, giving us some opposites in the right side and a y plus 3x in the left side, which we use the commutative property to change to 3x plus y is equal to 4. And then remember that a y is the same as 1y, so our a is 3, b is 1, and c is 4. Here's another example. This one has a fraction. So we're going to apply the definition of subtraction first. That'll make it a little harder to make a sign error. Then we're going to add negative 2/3 x to both sides. We mark out the opposites on the right, and we use the commutative property to write negative 2/3 x plus y equals negative 3. And now we're very close to standard form, but the negative 2/3 is not an integer, so we're going to multiply everything by 3. We apply the distributive property. 3 times negative 2/3 is negative 2, in this case negative 2x. 3 times y is 3y, and negative 3 times 3 is negative 9. It's now in standard form, but it's customary that a is non-negative. So we run a negative 1 through this equation, which is something I like to say, or more formally, we multiply both sides by negative 1, and now everything changes to its opposite. So originally it was negative 2x plus 3y equals negative 9, and we now have 2x take away 3y equals 9. And a is 2, b is negative 3, and c is 9. Pay special attention. When we subtract the 3y, we know that when we're trying to figure out what b is, that means that b is negative 3. One more example with fractions. In order to get rid of all of these fractions, we're looking for the lowest common denominator for sixths, thirds, and fourths, and that lowest common denominator is 12. This is a little more complicated problem, so I'm going to show a little more work than the previous one where I used the distributive property. I want to make sure that I show the work for 12 times 1/6 x and 12 times 2/3, and then on the right side 3/4 y times 12. I apply what I learned years ago to multiply fractions, and I cancel out, and then I try to show my work neatly so I can now do the multiplications, giving me 2x plus 8 equals 9y. It's very close to standard form, but the x and the y terms must be on the same side. And that brings me to a mnemonic device which states, change the side, change the sign. I could just do that real quick, but I'm going to show the work. And the work is that we're adding both a negative 9y and a negative 8 to both sides. So on the left side, we find there's a negative 8 and a positive 8, and they're opposites, and we cross them out. On the right side, we have a 9y and a negative 9y, and they're opposites, so we cross them out. And that leaves us with negative 9y plus 2x equals negative 8. And I hope that helps you understand why some people say, change the side, change the sign, because the 8, which was on the left, is now a negative 8 on the right, And the 9y that was on the right is now a negative 9y on the left. And the final thing we're going to do is rewrite the left side using the commutative property and also changing the plus negative 9y to subtract 9y. And we can identify that A is 2, B is negative 9, and C is negative 8. Well, a horizontal line such as y is equal to 42 is both in standard form and slope-intercept form, because in standard form we can add 0x so that it reads 0x plus y equals 42, and A is 0, B is 1, C is 42. And for slope-intercept form, we can add a 0x on the other side so that it reads y equals 0x plus 42, and that makes M, the slope, 0, and B, the y-intercept, 42. A vertical line is written in standard form because it can be rewritten as x plus 0, y equals 23, so that A is 1, B is 0, and C is 23. I stated earlier that both A and B cannot be 0, but either one can be 0 as long as the other one is not 0. Equations in standard form are usually written in lowest terms, and that's a synonym for saying that A, B, and C have to be relatively prime. It's much like putting fractions in lowest terms. Here's an example. We have 6x plus 12y equals 18. And the 6, the 12, and the 18 are all divisible by 6. So we divide both sides by 6, giving us x plus 2y equals 3. And so now A is 1, B is 2, and C is 3. And the 1, 2, and 3 are considered to be relatively prime because their greatest common factor is 1. Here's another example. We're starting with 9x minus 12y equals negative 24. The greatest common factor of 9, 12, and 24 is 3. So we divide everything by 3, and we're left with 3x, take away 4y, equals negative 8. And in this case, A is 3, B is negative 4, C is negative 8. And again, the greatest common factor for those three numbers is 1. So the one at the bottom is the preferable way to write this equation in standard form. Once again, the two equations are equivalent equations, but we prefer to write it the way it's written at the bottom. And then in a previous lesson, we were looking at this equation, 5x plus 7y equals 24. We used graphing to discover that the slope was negative 5/7. And I mentioned that there was a 5 and a 7 in the equation, and I said there was a relationship. And now we know the relationship. That equation was in standard form, but in the previous lesson we hadn't covered standard form yet. And so it can now be stated, something that's true about standard form, that if an equation is written in standard form, the slope is the opposite of A divided by B. So going back to the previous example, A is 5, B is 7. A divided by B is 5/7, and the opposite, of course, is negative 5/7. Let's take a look at a couple of examples. 2x plus 3y equals 12. A is 2, B is 3. That's 2/3, and the opposite, of course, would be negative 2/3. Another example, a similar equation, but not the same. 2x take away 3y equals 9. A is 2, B is negative 3. And to help us remember that B is negative 3, we're going to subtract 3y to add negative 3y. And then we have the opposite of 2 divided by negative 3, which we can simplify to just plain 2/3. And in our final example, we have 3x plus y equals 4. We remind ourselves that y is the same as 1y. The opposite of 3 divided by 1 then, in lowest terms, is negative 3. To summarize, another special way to write linear equations is called standard form. A, B, and C are usually integers. A is usually non-negative. A and B cannot both be 0. And A, B, and C are usually relatively prime. And the slope of an equation written in standard form is that the slope is equal to the opposite of A divided by B.